Hi, I'm Rich from Inside HPC, and we're here at the Portland Group booth at SC11. I'm here with Doug Miles. Doug, we've been hearing a lot about PGI Accelerators compilers. Why are these so important? Why am I hearing all this?
Well, PGI Accelerator Compilers are designed to lower the barrier to entry for GPU and accelerator computing. It's a set of directive-based extensions to Fortran and C that allows programmers, by entering portable directives in Fortran or pragmas in C, to offload code from the host CPU to a GPU, optimize data movement between the host and GPU device, optimize the kernel schedule. So it really is designed so that your code will remain 100% portable. It improves productivity. Sometimes with as few as 2 directives you can offload code to a GPU, and then incrementally, of course, you have to tune, but much more productive environment than lower level programming models. And the model is really designed to allow you to extract most of the performance of an accelerator. So portability, productivity, performance, those are really the key factors driving all of the interest in that model.
So on the performance track, I noticed you guys are part of NVIDIA's promotion, this 2x in 4 weeks thing. How does that work?
Well, that really started with a few organic success stories. People were able to get impressive, not 100x speedups, but 2x, 4x, 5x in a very short period of time. And between discussions with NVIDIA and PGI, we decided to formalize that into a program where we put together some material on the NVIDIA website. It allows people to determine, is my application appropriate for acceleration with directives? And a lot of material that will help you adapt your code. There is an offer of a 30-day free license of the PGI compiler. And if you're unable to get a 2x speed up in 4 weeks, NVIDIA and PGI will provide some limited consulting from a Cuda expert or a PGI accelerator expert to try to help you get there.
To get to that 2x performance or better. Terrific. So let's talk about directives. Where are they going from here?
Well, there have been a few directive-based models available, and there was a big announcement yesterday about OpenACC, which is an open accelerator programming model that is directive-based. Again, similar to OpenMP, it's largely modeled on the PGI Accelerator programming model. There are some slightly different spellings and some additional functionality. But really, it's a coalescing of the 3 major directive-based compilers into a common standard, which when we defined this model 3 years ago, that was our target. It was designed to be both vendor independent and target independent, and so this is all going on the path that we originally intended when we first defined the model a few years ago.
Where does that leave Cuda, though?
Well, Cuda is still very important. PGI is implementing Cuda extensions in our C, C++, and have had for a while in our Fortran compiler. And Cuda gives the programmer complete control over what's happening in the hardware. So you can manage memory explicitly, and it's important. What directives do is allow you to get started quickly, and you can see significant performance improvements. Cuda allows you to go as low as you want to go. And in that sense, it's always going to be important as a GPU computing model.
So, we've been hearing a lot about consumer electronics, right, and ARM-based processors being the future on the road to exascale. Are you guys working on ARM? Do you have any plans there?
So the Portland Group is a part of ST Microelectronics, which is a very large semiconductor manufacturer and one of the largest vendors of ARM processor-based systems on chip, SoCs, in the world. And so we know a little bit about the ARM processor space, and we are watching it very closely. It's very interesting to us, and I think that while we don't have any plans today, we have not made any announcements. We'll be in a position to move very quickly if something develops there. And it looks like there's a commercial opportunity for for compilers in HPC in that area.
Sure. Is it just too early for there to be an ecosystem on HPC
Well,
there? It's just very fledgling.
Certainly there's a lot of software infrastructure that needs to be developed, and what you're seeing here is seeds of that. And we are a commercial compiler company, so we don't look at it from a pure research standpoint. We look at both, there needs to be some business value there. And so in that sense, we need to move a little bit slower than people at universities, say, who can be very, very aggressive in that sense.